So our next speaker is David Wujic. I hope I pronounced that correctly.
Good enough.
More or less. He's going to talk about Python monorepos. So give him a warm welcome.
Okay, do you hear me? Good, good. Okay, welcome to this session about Python monorepos and the Polylith developer experience. So my name is David Wujic. I'm a developer and I live and work in Stockholm, Sweden. So I work as a developer at a consultancy called Polylith. So I'm mostly into Python, like today I'm like 100% Python, but I've also been working with like functional programming, Clojure, and a lot of Node.js, and I was for many years in the Microsoft space, like .NET and C# and stuff like that. But today is like all in Python. So I would like to begin by try to sort of the definitions of this terminology. So starting about monorepos, so like Python monorepos. What's that? How does that work? And this thing called Polylith, how does that come in and what problems does it solve? So let's say that we have our Python service or app. Maybe it's a fast API service with a lot of endpoints, and it kind of solves every business problem in the place you work today. So a monorepo wouldn't make any sense there, because you have just your one service. But at least from my experience, the last couple of assignments, or the companies or teams that I've joined, we have like built larger apps or maybe platforms. At one place we have developed an e-commerce platform. So a common approach to these bigger things is that you use like a microservice approach. Like you separate the different parts of that platform or app into separate deployable artifacts. So maybe let's say that you have an e-commerce application or platform. Maybe you have one place where you deal with your products and a different place where you deal with the prices of that products, or maybe stock and ordering and stuff. So they are like different parts. So the thing that I have noticed, at least the places I've been, is that when you have these microservice setup, many different services, you often have them in different repositories, different Git repositories. So you might have, like, you start small and maybe you develop new things, and it's starting to grow. You have more and more services that you deploy and run. So I think a common approach for teams that has this setup is that you usually agree on that it's a good idea that your services, let's say that all of them are Python, are structured in this kind of same kind of way. So you use the same tooling, like linting tools, type checkers, and even the folder structure. So when developers are going to solve problems in different repos, they will kind of know the structure and how to use the tooling. Maybe you use make or just or something like that. I didn't start this. Okay, so but after a while, after some time of development, maybe all teams doesn't work on all services all the time. So you might have started to diverge a bit. You develop your new services and you use new tools, maybe new versions of the same tools, or different, like maybe you had Sanic as a web server in one service and you have Fast API in this service. So you're starting to diverge because things evolve and tools are developed. And also maybe you get new ideas on how to structure your code. You see this third one has this source layout. So things might start to look a little bit different. I think that's at least a risk or a probability. But our risk of having these things is that, let's say that this team works on this service, and they need this a problem to be solved, and they know that that problem was solved in this service. So we need a little bit of code from here. So the easiest approach is just to copy and paste it. And I think that's quite common that you do that. But the risk of that is that you have starting to have duplications in your code base, like duplicated code in your platform. And the worst scenario is that if that part of the code has a bug, then you need to go or if you need to change something, you need to go to many places and change that. But a common way of solving these kinds of problems is to extract the common code into libraries. So you can do that. What was I going to say? Yeah, but then you will have another repo to maintain. And library is really good, but then you need to have an agreement on versioning. Maybe you use semantic versioning, and if you want to make sure that most of the services run on the latest version, you need to keep all the services up to date. So there are a couple of trade-offs and risks with this kind of setup, especially as the platform grows and you have starting to have a lot of services and a lot of code. I was going to say something about libraries. Yes, some code is like almost too tiny, too small to start creating like an entire library of it. Maybe it's like almost like a code snippet. You may maybe you have like this dictionary parsing thing, or how to set up a logger that you want to do in the same way in all the places. So maybe it's like not worth making a library and versioning and deploying and things like that. So it's just easier to copy and paste. So one solution to that problem would be to just grab all the code and put them in the same Git repo, same repo. So, and that would be my definition of a monorepo. So you have all the code, but you deploy separate things from it independently. So a monolith, it's like a related to it, but a monolith is just if you have your repo and you have one thing that you deploy. So a monorepo is where you have all the code in one place, but you deploy several different things. But managing a monorepo can be really, really difficult. I know I've been to join teams that has like a monorepo set up, and with custom scripts and symlinks and all this kind of magic to make everything work. And when you open your IDE, at one place you couldn't even navigate the code because it was the editor didn't really understand the references. So there are problems with monorepos. It's not like the perfect solution just because you have a monorepo. But this is where this Polylith thing comes in. So Polylith is an architecture, or basically it's a way of structuring your monorepo basically. And it's really, really simple. It's almost like it's too simple. When I was introduced to this, I was like, if it was this simple, why didn't anyone come up with this before, So, but the basic idea, the main thing is that you structure your monorepo into, and you have three top folders. One called bases, another called components, and a third one called projects. And if we see, let's say that we have all these different services in different repos, what's common between these is that they have some sort of an entry point. If it's a fast API service, you have this where you define your entry points with the decorator and things like that. Or if it's a CLI, you probably have a main function. So they probably have some sort of an entry point. And those things you would put in the bases folder. So ideally, you basically have that entry point but it doesn't do much logic. It calls the other code in your repository. So your entry points should be like thin. And the rest of the Python code you put in the components folder. So if you would just copy it, it wouldn't look as like the ideal Polylith way. But eventually, you will end up in having a list of namespace packages that ideally are very thin. So let's say that you have this folder structure, but you identify the different logical parts of it and extract them into smaller namespace packages. And that's what's called components. So the ideal is that they are flat and small. And it can be like a tech component. It can be something that does dictionary parsing or something really simple, or it can be more feature-like, maybe like a Kafka consumer producer. So it doesn't have to be the same size. It can be different sizes, but logically they are like separated. So you probably would have a long list of different components there. And just by looking at that folder, you will actually get a quick overview over what's in this monorepo. If you have a fairly good naming in your namespace packages, you will understand what's in there. And the third part is projects. And this is where you would put all the PyProject TOML files. So you don't have any Python code in there, but you have like the thing that you want to deploy. You have the infrastructure of it, like basically the PyProject TOML, maybe Docker files and things like that. The configuration of the actual project. And the idea is that each project reference to the code that lives in the components and bases. So if there are several projects using the same component, they will use the same version of it. And this thing is what the structure of this is what's called the Polylith workspace. So you have the bases, components, and projects. But what we also have at the top level is a PyProject TOML file, and that will contain all the bases, all the components, all your code, and all the third-party libraries that you use across the monorepo. So that means that, and this one is meant for development, because we develop at the top level. The projects folder is basically where you deploy things, but during development, you are working at the top level. And that means that you have one virtual environment, and that virtual environment will have all the code in your monorepo. And that also means that you have one set of linting rules, one set of like type checking rules, and all the kind of good things that we usually have in our projects. You have one set of rules for the entire code base. So the development experience is basically like a monolithical. So you have this kind of monolithical developer experience from it. And the developer experience is so important that you even have a separate folder for it, because you might want, depending on what kind of where you want to begin if you want to start a new project. Some people want to start right away defining an endpoint and work your way from there. Other might want to experiment and try things out. And if you want to do that, you have a place where you can put like your if you use like PyCharm, you have Scratch files. It's something like that, but you will version them. You have your file, your Python module in the development folder, so you can keep it and experiment. And when you're ready, you can extract code into a component maybe or a base. So it's like a playground. You can also have like scripts, things that don't fit in like in a regular structure. Maybe you have like one-off scripts that you run like once a month or so. You can put them there too. So I mentioned the Polylith thing is an architecture. So looking at it from like a sort of a high level. So we have something called bricks. And bricks is the common name for components and bases. And the bricks, Polylith really likes Lego, so it's about, thank you, it's about Lego bricks. And that's why we have a folder called bases. Because if you have not developed Lego, but built Lego, maybe you have used a Lego base plate where you put your bricks on top of it. So the bases is the thin layer, the entry points to your app. So that's the kind of the metaphor from a Polylith perspective. And the Lego bricks that you build things from is the components. And then we have something called libraries, which is basically the third-party libraries, dependencies that we use. So fast API, requests, Pydantic, all that good stuff that we need in our projects. So the combination of a selection of libraries and a selection of bricks becomes a project. So in Polylith we have one or several projects. And each project just picks the bricks and the libraries that it needs to be deployed. So, and for Python, we have, with this kind of setup, you probably want some tooling support. So this is the thing that I have developed. It's called Python Tools for the Polylith architecture. And it has been picked up in the Python community, and I'm really, really, really happy about it. And it's like if you visit the page, you will find a discussions forum where people have it's a kind of active forum. So I'm really, really happy that it's at that state now. So the Python tools for the Polylith architecture is basically, the main idea is that it will visualize your monorepo. So you can see what's in there, what are the smaller parts, what is the big picture, and there's also like helper commands. If you're going to create a component, if you're going to create a project, it will use that like by templating basically. So one of the commands, the most straightforward one, is the poly info command. So you type poly and then there is a command. And the info command will show you an overview of your monorepo. So I ran this command in my example repository, which is tiny. It's like simplistic, and it's almost like it's too simplistic. It's very little code. But in a real world monorepo, you will probably have a lot more code. So what this command will show you is all the bricks, all the bases and components. That's why they have different color. It will also show all the projects that you have in your monorepo. And it will show you the connection between the two. So you can see where one brick is used in which projects. So you get this kind of overview of your repository. There's also a libs command where you can find out what third-party libraries are used in bricks. So you can see, okay, this brick uses Pydantic. And you can also see where the libraries are used in which projects. And then we have depends or depth command, which is I use it mostly for like refactoring purposes, because it shows you the relation between the bases and components. So if you remember, I mentioned the components are like Lego bricks, but one component can be made out of other components. So it doesn't have to be like a one-to-one. So you can, if you have a small, tiny like utility component, it might be used in several other components. So this command will show you like a matrix of how they relate to each other. So again, this example is so it will just output a tiny matrix, have a very little code. But in a real world scenario, you would have a lot bigger. You can also zoom into an individual brick to see. I think I zoomed into a brick called message. So I can see where it's used, and I can see what it's using. So you can like follow the kind of import usages by that command. And I think this command, polydiff, is I think it's one of the most useful, especially from a deployment perspective. Because let's say that you change something in one brick. In this example, I've changed the Kafka brick, the Kafka component. I'll change something, and if I'm going to merge that into the main branch, I don't want to like deploy all the project all the time. I don't want to deploy everything all the time, but I want to deploy the projects that are dependent on this change or affected by this change. So this diff command will show you, okay, so the Kafka brick is used in these two projects, but it's not used in these other projects. So this is useful information for your CI, so you can determine on what to do when merging code. There's also like a CI-friendly shorter, so you can like programmatically figure things out. I think this was my last slide, actually. And thank you for listening. Any questions? Yeah, I think you were first.
If you can only have one virtual environment.
Hi, thank you for the wonderful talk. If you could only have one virtual environment when you're developing, how does that work with if different projects need different Python versions?
Good question. So the basic idea with this Polylith thing is that you ideally have the same version across your entire repo, because everything you have there is shared code. So that's the ideal situation. But if you need something different for a while, then you can create a new component that has that separate version, and in your development environment you can switch on and off the different components. But ideally you should have the same version across the entire monorepo.
Thank you.
Yeah.
Thank you. Could you make a brief comparison with other tools like Poetry, please?
Yes.
Thank you.
Actually, the tooling that I have developed is built on top of tools like Poetry. So, because I didn't want to like reinvent how to install dependencies, and because Poetry and all of these other tools has really good support for that. So I built it on top of tools like that. So if you're a Poetry user, there's a Poetry plugin for Polylith. So if you use UV, you use a separate CLI. So it supports, I think, almost every patch and PDM and a lot of these package management and the dependency tools. So it's not a competitor to Poetry, but it's like an add-on, basically.
Hi, thank you for your talk.
Oh.
I think we're addressing a very interesting problem here, relevant to many of us. So what I can see happening is, let's say you have a component doing AI training, model training, and a component doing an API. I can see it happening that I have a brick for my AI model, and that's then used by another team, another dev, for the API, which is not what it's meant for. How do we avoid that?
Okay, does the other team use it because they think they want something in there? Or
Yeah.
Okay. Yeah, I think maybe that's like a communication problem. But if it's possible, maybe if you could extract the parts that the team needs from that AI component into a separate component, so the AI component can use it, and the other team can also use it. So my suggestion would be to try to split that part out to find the shared need for that everyone needs, basically.
Okay, so it's about communication, really.
Yeah, I would say so. Yeah.
Okay, thank you.
Hi. My question is related to testing. How would you structure your test, and within CI, how is it possible to only run tests for a specific project if you have components sharing like multiple projects and things like that? How would you optimize that to not run your full test suite every time something changes for one component?
Yeah, good question. Polylith doesn't have its own test runner, so it relies on if you have like the PyTest. or any other tool. But what it can deliver is a list of the changed bricks. So PyTest has this query or marker feature. So you can use it if you have marked up your tests or named them in a special way that's kind of related to the brick that is changed. Then you get a nice query from a Polylith command.
Right,
so
thanks.
yeah.
Thank you for the presentation. I have a bit of a hypothetical question. Let's say I have a project where I predict soon I will have multiple components, but currently I have like multiple projects. Does the tool expect you to have one singular virtual environment, or do you make a virtual environment per project? How does it handle it?
So the recommendation is to have one virtual environment at the top, so you have everything. But I know that some Polylith teams today, because they want to develop in isolation for that specific project, so they kind of navigate down to the project folder and start a virtual environment there. But that's not what I would recommend. But you can do that if you have these kind of needs and need to separate things. But the ideal situation is that you have your virtual environment at the top and one virtual, or whatever, but wherever you want to have it, but it's just one virtual environment. So you have access to everything.
Yeah, wouldn't it cause it like a bloated virtual environment where you might get lost in the dependencies? That's what I'm afraid of. That's just the last question.
By having one virtual.
Yeah, like I have completely like separate. I'm a data engineer, so I have like completely separate data processing versus some like DBT, which is a completely different package.
Okay.
And there's a completely separate.
Okay, I think it means that the virtual environment would contain everything, but the team only needs this part. Well, I think that's a trade-off, but I would go for that anyway, because then if you find out there's a connection between the two teams, that hey, both of us needs this part, then you can start share code, even though they are completely different business domains. So that's what you will probably discover when you have this Monorepo and this Polylith setup, that you have probably more things in common that you might think in the beginning, just by separating out the code in smaller parts. Yeah.
Perfect. Thank you.
So thank you very much for all these questions, and thank you to David for this excellent talk. So give him a thank you.